This project involves designing, programming, and visualizing an industrial automation sequence using Siemens TIA Portal, Totally Integrated Automation Portal. The core objective is to control the operation of 3 motors in a sequential, cyclical manner. The system utilizes a Siemens PLC, S7-1200 or S7-1500, with its digital input module to read commands from 2 physical push buttons, start and stop, and its digital output module to energize motor contactor coils. An HMI, human-machine interface panel, is integrated to provide real-time visualization, operational feedback, and a platform to demonstrate the effects of timing and interlock logic within the control system. Logic breakdown. Master control and sealing circuit, stop function. The stop PB is programmed as a normally closed NC contact. This is a standard safety practice. If the wire to the stop button breaks, the PLC interprets it as a stop command. The start PB is a normally open NO contact that momentarily initiates the sequence. Motor 1 activation and timing. The motor 1 coil is energized by the start PB or its own motor 1 coil NO contact, seal in or hold. An NC contact of motor 2 coil is placed in series with the motor 1 coil. This ensures motor 1 can only run if motors 2 are de-energized, interlocking. In parallel with the motor 1 coil, the input IN of timer 1, TON, on-delay timer, is enabled. Timer 1 is configured with a preset time, PT, of 10 seconds. When timer 1 completes its timing, its output bit, timer1.Q, turns on. Motor 2 activation and timing. The motor 2 coil is energized by the timer1.Q contact, which acts as the trigger for the next stage. A sealing contact, motor 2 coil NO, maintains power to the coil once activated. An NC contact of motor 3 coil is placed in series, preventing motor 2 from running simultaneously with motor 3. The timer 2 input is enabled in parallel with the motor 2 coil, starting its 10-second timing sequence. The activation of timer2.Q also triggers the logic for motor 3. Motor 3 activation and timing. The motor 3 coil is energized by the timer2.Q contact. A sealing contact, motor 3 coil NO, maintains its state. NC contacts of motor 1 coil provide the necessary interlocking. The timer 3 input is enabled. Upon reaching its preset time, 10 seconds, timer 3.Q becomes true. This contact is used to restart the entire cycle by acting as a parallel trigger to the start PB on rung 1, re-energizing motor 1 coil and beginning the sequence anew. The timer 3.Q output is connected in parallel with the start PB contact. This creates the automatic restart condition. An NC contact of the stop PB is placed in the main power rail for the entire logic. When the stop PB is pressed, this contact opens, de-energizing all coils and resetting all timers, bringing the entire process to a controlled halt. This sequential control scheme is a fundamental building block in industrial automation. Practical implementations include conveyor systems. In a multi-stage sorting or assembly line, this logic prevents material pileups. The first conveyor, motor 1, starts, and after a delay allowing material to advance, the second, motor 2, and third, motor 3, engage sequentially. The cyclical nature can represent a batch process. HVAC systems, sequentially starting large ventilation fans or compressors to manage inrush current and prevent a simultaneous startup surge on the electrical supply.
Detailing the specific modifications from the original ladder logic. Optimizing code structure for SCL syntax. Ensuring all ladder logic elements have SCL equivalents. Maintaining safety features and timing requirements. When the start push button is pressed, we initiate the sequence by energizing motor 01 while ensuring motors 02 and 03 are off. Starting timer 1 with a 5-second preset time. This creates the first stage of our sequential start. When timer 1 completes its 5-second count, we de-energize motor 01 and energize motor 02. Verify motor 03 remains off. Start timer 2 for another 5-second delay. This represents the transition to the second stage. Upon timer 2 reaching its 5-second completion, motor 03 is energized. Motors 01 and 02 are de-energized. This completes the 3-stage starting sequence. When the stop push button is activated at any time, all 3 motors are immediately de-energized. Both timers are reset and disabled. The system returns to its idle state, ready for the next start command. This program creates a sequential motor control system where 3 motors operate in rotation, each running for 5 seconds before passing control to the next motor in the sequence. The system provides complete operator control through start and stop push buttons while ensuring safe, timed transitions between operational states.
Simulation, testing, and HMI visualization, compilation and download. The project is first compiled. The TIA portal software checks for syntax errors, missing tags, or inconsistent data types. Upon successful compilation, the logic is downloaded to the simulation PLSIM, or the physical hardware. This visualization bridges the gap between abstract ladder logic and tangible system behavior. HMI integration for enhanced visualization. An HMI screen is designed to mirror the physical system. It includes graphical elements, 3 motor icons that change color, gray to green, when the corresponding motor coil tag is true, illuminated push buttons for start and stop. Green lines indicate a continuous power flow from the left power rail through closed contacts to the output coils. This allows for real-time debugging, showing exactly which conditions are met and which outputs are energized.